So we're going to have a look through the answers here to the 1.9 chemical analysis questions. But again, just to reinforce, you already have the mark schemes to these questions. So just use this video if you get stuck on one and the mark scheme doesn't make sense, and I'll be explaining a wee bit more detail in this video, so you can skip forward, skip back as you need to. Question 1 opens with the definition. What's meant by the term solvent? Again, this is all your notes. There's a wee bit of leeway with how you express it. There's different ways you can word it, but essentially just means you have a liquid that dissolves another substance. Or you could say a solute. Part B is a bit of a strange question. Explain how you'd identify which liquid is water. Give the full chemical name for any substance used to test the liquid. So I say this is a strange question. It's a 6-mark question, but doesn't seem to be that much content that covers. Yes, you do have the test for all in your notes, but it's hard to see how that actually comes to 6 marks. It is one of those things, you're not writing many words, but those words do get you a lot of marks because there's a lot of detail actually in what you're writing for this. So what you have to mention, again, obviously the picture's gone, but you can assume there's a few liquids in that photo. To have to describe how you test it logically, so you wouldn't just mix them all together or just test one. The idea that you test them all after each other. So you got first point, which is just you test each sample separately. And you have to put that point in just because it says how would you do this? How would you identify from a range of different liquids that's water? So you have to get a wee bit of kind of practical guidance. But the rest of the points are kind of just one word kind of marks for bits of detail. So the fact you're using anhydrous copper sulfate actually gets you 2 marks, because one mark for anhydrous, 1 mark for copper sulfate. There's a bit of detail there. The colour change you should expect should be white to blue. That's another 2 marks. Again, was correct. And the idea, just to reinforce, I know it kind of seems a bit stupid to have to write this down, but you have to show that that's what you expect for water, because remember, you're trying to identify the water. So you need to say that whichever one turns blue is going to be the one that is water. So we mark for saying that that indicates the presence of water. So that's really all you needed. Not many words for that. It's quite a dense sort of 6-mark question. Question 2, explain how a flame test is carried out. Now, I know in your notes you've got a lot of detail about cleaning it. A lot of times in mark schemes they don't give you marks for the cleaning of the wire, because you could argue in some situations you might do a flame test and you might have a brand new nichrome wire, which obviously you wouldn't need to clean. So in that case you just need to do the end of the method. So often in the mark scheme that's all you see. But you do have to mention what that wire is. So the first mark is the idea that you've got a nichrome wire. Second mark is you have to dip it in concentrated hydrochloric acid and into the sample. Remember, that is to get the sample to stick to the wire. And then place it into, importantly, a blue Bunsen burner flame. This flame test will not work that well if you're using a safety flame. It has to be the roaring flame. And observe colour. That's all you need for 3 marks. Question 3. Hydrochloric acid reacts with bases to form salts such as sodium chloride and zinc chloride. A mouthwash is thought to contain both these salts. So you get a mixture of sodium chloride and zinc chloride. Describe how you can confirm that the mouthwash contains sodium ions. Don't overthink that. You have only got one way in your notes that you can test for something being a sodium ion. That is a flame test. It doesn't ask for practical methods, so it's fine just to write the word flame test. And just your observation for that, you can either write yellow flame or orange flame, but not yellow orange. Just pick one colour. So I'll go for yellow flame for this one. Question 4 is about separating techniques. It gives you 3 different methods which you should recognise: evaporation, filtration and distillation. Which method would be most suitable for obtaining water from a salt solution? Again, you have to read the question carefully. Both method 1 and method 3 you can use to separate salt and water, but with method 1 you lose the water, but method 3 you keep the water. So what will be most suitable for obtaining water from salt solution? You want to keep the water, therefore it's method 3, distillation. Most suitable for removing sand from a mixture of sand and water. So sand obviously is insoluble. So the easiest way for you to remove an insoluble solid from a liquid is just to filter it. So that's method 2. You could argue 1 and 3 would still work, but it's not the most suitable method. This is by far quicker than these two methods. Explain for the way method 2 would not be suitable to separate copper 2 sulfate from copper 2 sulfate solution. The key word there is solution. You cannot separate dissolved solids from a liquid by filtering it. Because it's dissolved, all the solid is broken up in really, really small particles, which will go straight through the filter paper. So just the idea that the copper sulfate is dissolved. That's all you actually need for the mark scheme, but I would probably add in a wee bit just to say would go through the filter paper. So that makes more sense to me as an answer. What general term is used for liquid A collected in method 2 and liquid B collected in method 3? A is a simpler one. You should know from first year it's a filtrate, it goes through the filter. More of a niche term here, less common. B, it goes through the distillation apparatus, therefore it's called the distillate. Question 5, about chromatography. So it gives you a result from a chromatography experiment. In this question, you're not asking for RF values, but just be aware that that could be something that could come up in an exam. You could have to measure the distance travelled by the spots and distance travelled by the solvent to work out RF, but not in this one. Which ink contains 4 different compounds? Again, you're sticking for 4 compounds, you have 4 spots, so 1, 2, 3, 4 must be blue ink. Which ink contained the most soluble component? Now that's a trickier question. The more soluble a component or spot is, the higher up the paper it will go, because it's very soluble in the mobile phase, the liquid that's carrying everything up. So you're looking for the highest spot to work out the most soluble spot. And again, that's found here, which is part of blue ink. So blue ink contains the most soluble component. Which 2 inks contain 1 common component? So you're looking for 2 inks which have the same spot at the same RF or same height up the paper. Again, you have to pick carefully, but there's only 2 spots which are pretty much identical in terms of their level, and it's this spot and this spot. If they're spots at the same level, you can assume that they are the same spot in this experiment. So these 2 inks must contain the same kind of ingredient, which is found in both. So yellow and blue ink have the common component. What do you understand by the term solvent? Again, we've had that before. The liquid in which a solute dissolves. And which ink is a pure substance? You're looking for one of the spots should just have 1 dot by itself, and that is the green ink. Therefore, it must be pure. As a pure substance is something that contains only 1 substance.